The Innovent was designed for research, and so both the commercial companies and specific universities, government labs. The Innovent is really a key feeder system into our binder jetting technology.
What we wanted to create was a tool for researchers and developers, companies, universities alike, where maybe they have a very expensive powder, to limit their investment in discovering whether or not 3D printing could add value for them, so you can get a whole lot of research done for a lot better cost.
The Innovent definitely saves us time in our research, and time is critical and no matter what you're doing. And the way it saves us time is that it's easier to clean out the system, to change out for a different powder. It's easier to transition from a build to the curing to the sintering. It's everything's just a lot smaller and a lot more nimble, and it just gets you through the process much quicker.
Universities are the key to driving technology in this country. They feed a lot of commercial companies, and so when you look at new advancements in research, they are a key part of that.
Here at Carnegie Mellon, we consider ourselves a leader in additive manufacturing education. Having this Innovent allows us to add an additional type of metals additive manufacturing technology to our laboratory and to our suite of technologies that we have here.
What we think this is going to do at the university level is enable a whole different kind of creativity. We think that from a design standpoint, you're going to be able to explore designs that you would have never considered before.
So last fall, the first semester that we had it, I worked with building parts for our freshman mechanical engineers, as well as allowing students in a material science class to actually design some parts in groups. And then we printed those on the Innovent. They got to learn about what you need to do to design a part for additive manufacturing, what kind of post-processing was involved. So that was a really great experience for them.
So one of the really nice things about the equipment is it comes with very nice software. You can actually watch the part as it's being built.
You can see what layer you're on as the print is progressing. And then there's this great three-dimensional interface where you can see where all the parts are in your build, and you can pack that build really efficiently.
Building on the ExOne Innovent is a little bit quicker. It allows us to go through and build large numbers of parts in batches, so that allows us to reach more students more effectively. Also, the materials associated with building on the Innovent are a little less expensive than some of the other materials with the other technologies.
The beauty of the Innovent is that it scales directly with the Inflex. So all the material development and process parameter development that you do on the Innovent transfers directly over to the Inflex. So you don't have to commit to large builds or large amounts of powder with the Innovent until you're ready to scale it up on the Inflex.
So when you look at the factory of the future, there's a lot of new advancements, the Internet of Things, sensing technologies, robotics, and certainly additive manufacturing is a big part of that.
We recognize that if 3D printing is going to take off like CNC machining, we've got to have people trained in how to use the equipment. In terms of, like, say, a university program, yeah, it's just a great thing for students to come in and learn on. I mean, like, this is the future.